All right. Hello, everybody. Welcome into our virtual co-opting AI space. Very excited to have you. Welcome back to a new co-opting AI event. I'm Mona Sloan. I'm a sociologist of artificial intelligence. I am the founder and host of the co-opting AI series, which have been happening since 2019. And I think we're coming up to our 40th conversation with, over the years, over 100 people, which is very exciting. Now, speaking of exciting and news, since we had our last co-opting AI conversation about language, very apt topic, in the spring of 23, a few things have changed. I have left the amazing city of New York to become an assistant professor of data science and media studies at the University of Virginia, which I'm very happy about. Here at UVA, I run Sloan Lab, which is my research group that's growing very quickly, that conducts empirical research on the implications of technology for the organization of social life. I'm very delighted that here at UVA, the Co-opting AI series has found a strong partner in the Karsh Institute of Democracy, while our beloved NYU Institute for Public Knowledge remains a cherished and trusted supporter of the series. And at this point, a heartfelt thanks to both institutes and the folks who make this series happen together with us. These are not the only exciting news I want to share with you today. I want to share that I have partnered with the University of California Press to launch a new academic book series called, you guessed it, Co-opting AI. And the series was launched this month and will help readers better understand the social dimensions of AI. And the books will, like the series, ask bigger questions addressing key issues we face at the dawn of the new century: inequality, injustice, the future of work, democracy and governance, the climate emergency, the economy, education, health, our physical spaces, and their intersection with AI and what we imagine AI to be. And as I am, for the very first time, coming to you from the grounds of the University of Virginia, I want to underline that here at UVA's Sloan Lab, we acknowledge that the land we learn and work on is the homeland and traditional territory of the Monacan Indian Nation. We pay respect to their elders and knowledge keepers, past and present, and we also acknowledge and pay respect to the enslaved Africans, enslaved laborers, and free Black laborers who built UVA, as well as their descendants. Now, today's Co-opting AI event is about the origins of AI, and I hope that the conversation today will help us trace the various but yet overlapping cultural, material, and political histories of AI. And against the backdrop of all that happened with OpenAI over the past days, that is a particularly apt moment to have this conversation. Now, we all tend to be very deeply embedded in the kinds of conversations that make up our milieu of our professional fields. I've been thinking about for many years now. As generative AI systems got swept into our everyday life, we had, again, conversations about a new AI summer. We're still experiencing that. So there always is this sort of connotation of newness, the new kid on the block, innovation that is accompanying those conversations, but that also stokes old fears about robot takeovers or sentient machines and so on. But however sudden this new reality feels to so many of us, it in fact emerges from a long and entangled history of mathematical thought, of data, of social organization and bureaucracy, of innovation, and, well, computers. And if we really want to understand AI and more democratically engage in a discourse about what our AI-infused futures could look like, then we not only need to understand the math behind AI, but its multi-layered histories and genealogies. And I couldn't think of better people to help us do that today. Please join me in welcoming Stephanie Dick, Kevin Driscoll, and Chris Wiggins, my wonderful panelists. And kicking us off today will be Dr. Stephanie Dick, who is an assistant professor in the School of Communication at Simon Fraser University, and she holds a PhD in History of Science from Harvard. Her work focuses on the history of computing, mathematics, and artificial intelligence since Second World War. She also does editorial work, for example, with Janet Abate on the wonderful book, Abstractions and Embodiments, New Histories of Computing and Society, which is a terrific book, by the way. Her first book project is called Making Up Minds, Computing and Proof in the Post-War United States. And that book explores attempts to reproduce human intelligence, mathematical intelligence in particular, in computers, and the theories of human cognitive faculties that informed these efforts. Her second book project, 2 books aren't enough, explores the development of early computerized law enforcement databanks in the 60s and 70s in the United States, along with the automated identification tools that were developed in tandem. Very important topic. She co-edits the Mining the Past column at the Harvard Data Science Review, serves on the editorial board of the IEEE Annals of the History of Computing, and also is a co-organizer of the annual SIGCIS conference. This is Stephanie. Okay. Following Stephanie will be Dr. Chris Wiggins, who is an associate professor of applied mathematics at Columbia. He also is the chief data scientist at the New York Times. At Columbia, he's a founding member of the executive committee of the Data Science Institute and of the Department of Applied Physics and Applied Mathematics, as well as the Department of Systems Biology. And he is affiliated faculty in statistics, so all the math at Columbia. He is a co-founder and co-organizer of Hack New York, a nonprofit which since 2010 has organized the Hack New York Fellows Program, which is a structured summer internship at New York City's startups. Before Chris went to Columbia, he was a Quran instructor at NYU, and he did get his PhD at Princeton in theoretical physics. Today, he's a fellow of the American Physical Society and is a recipient of Columbia's Venetian's Diversity Award. He has a book out too, which is called Data Science in Context, Foundations, Challenges, and Opportunities with Alfred Spector, Peter Norvig, and Jeanette Wing, which came out with Cambridge in 2022. And a year after, he co-wrote How Data Happened, a history from the age of reason to the age of algorithms with Matthew L. Jones, which came out with Morton just in March this year. Welcome, Chris. Thanks for joining us. And then closing us off will be my new UVA colleague. I'm the one who's new, but my UVA colleague, Kevin Driscoll, who is an associate professor in the Department of Media Studies at the University of Virginia. He specializes in technology, culture, and communication. And his recent research is focused on alternative histories of the internet, the politics of amateur telecommunications, and the moral economy of consumer software. Again, very, very current in the context of everything around OpenAI. Now, in collaboration with Julian Maillard from Indiana University, he published Minitel, Welcome to the Internet, a cultural and technological history of the French Videotex Network, which came out in 2017 with MIT. And he more recently published The Modem World, a prehistory of social media, out with Yale last year, which traces the origins of social media through the dial-up bulletin board systems of the 80s and 90s. Before coming to UVA, Kevin was a postdoc at Microsoft Research, and he has a PhD from the Annenberg School of Communication and Journalism at the University of Southern California, and also a Master of Science of Comparative Media Studies from MIT. You can find him at kevindriscoll.info. Enough of me. a few words about housekeeping, and then it's all history of AI. Each panelist, as per usual, has about 10 minutes, although we have had negotiations up to 11 and a half today. While our panelists are sharing their work, please do put your questions and comments in the Q&A box that you can see in your Zoom square. I will be collecting those and bringing those in when they're done with their provocations. So pop them in the chat as they pop into your hat. We have closed captions available. And this is all from me, and I'm handing it over to Stephanie. Thank you all for being here.
Thank you so much, Mona, and everyone for being here. It's really an honor to participate in this fantastic series and to be in conversation with Kevin and Chris. So this fall, as Mona alluded, I am at long last finally finishing my first book manuscript, Making Up Minds, Computing and Proof in the Post-War United States. And the book is about attempts to recreate mathematical intelligence, in particular in the computer. It's about attempts to automate mathematical theorem proving, mathematical reasoning, mathematical knowledge over the second half of the 20th century. And it's about what happened to those faculties as they were being abstracted and extracted away from people, as it were, and put into the machine. And one of the central through lines in all of my work has been the observation that basically any time someone announces that a computer has done a thing, that it's recognized a face, it's diagnosed a disease, it's composed a poem, it's proven a mathematical theorem, it's won a game of chess, that task has been redefined. Of necessity, it has been turned into the sort of thing that a computer can do. The task has had to be translated into the available computational operations. Its constitutive parts have to be represented in computer memory using the available data structures and programming languages and formalisms. The task has been translated such that the computer can have some purchase on it, as it were. But often this part of the story about the details of transforming concepts and implementing our ideas gets left out. We hear from technologists, we hear in the media that the computer has done this or that impressive hard thing, but we don't usually hear how that task has been redefined in order to make that accomplishment possible. So the story of AI, as I see it, is not a progress story in which computers are being made to do harder and harder and more impressive things. Instead, the story of AI, as I see it, is a story of more and more of the world being translated into the terms of the computer, redefined through the lens of what we think computers can and cannot do and the way in which they currently do it. So my work as a historian has largely been an archival exploration of what some of those transformations have looked like in practice. I want to know how knowledge has been redefined by those AI researchers in the 1960s who wanted to create huge databases of automated human expert knowledge, which, by the way, they mostly redefined as sets of inference and if-then rules. I want to know what reasoning is and how reasoning has been redefined by AI researchers who wanted to automate it. Reasoning, of course, is meant to pertain to what follows from what inferences and deductions are permissible? How do we get to sound conclusions based on the evidence we have, the assumptions we've made, or the axioms we've chosen? But in the history of computing, all kinds of new computer-oriented inference rules get introduced. And I suggest that reasoning is redefined in tandem. But these redefinitions, again, are often not centered in our discourses on AI. The very idea of the human, in fact, our capacities, our labor, our cognition, our limits and possibilities are consistently being remade and redefined in more ways than one alongside our technologies, especially those that were meant to pick out something uniquely human and reflect it back to us. This was one of the findings of Lucy Suchman's foundational work in human-machine reconfigurations, where she writes, quote, just what it means to be human-like and how the boundary between humans and non-humans is correspondingly drawn and redrawn is, of course, one of the matters in question. AI and robotics involve a kind of doubling or mimicry in the machine that works as a powerful disclosing agent for assumptions about the human, end quote. So the human, of course, is not a stable category fixed in the history of technology. It turns out that humanness is a relative concept. It's relative in the sense that it is consistently defined in opposition or in relation to some other. In the history of Western thinking, humanness has been defined in opposition to a great number of others. Humans have been defined relative to God and angels, what they have in common, what they don't. Humanness has been redefined and defined relative to different classes of animals and also machines, from water clocks to mechanical calculators. But I think it is also important to acknowledge in any conversation about the origins of AI that humanness is also a category that has done great violence. Western Europeans and Americans in service of colonial and imperial ends have also defined humanness in opposition to other people, those they wished to colonize or control or enslave or exclude or exterminate. And this violence has historically often been justified by the dehumanization of those people. And often, in turn, that dehumanization has been done through the denial of the higher cognitive faculties, as they're called: intelligence, right reasoning, rationality. European thinkers proposed that the people they colonized and enslaved lacked intelligence, lacked the capacity for right reasoning, the capacity for rationality, and as justification for the imposition of Western control over them, those faculties were withheld. Women, too, of course, have been denied the capacity for these higher human faculties, compromised as we are by emotions and mental weaknesses of various forms. So those same faculties at the heart of AI, right reasoning, intelligence, rationality, that computers have been so often celebrated for perfecting, for advancing, for attaining, have been denied to so many people in the history of colonialism that I think it's very striking to see how quickly some American researchers will say the computer can do all of these things in light of the many centuries of Western claims that various people cannot. The history of AI is in part a history of those cognitive faculties and the political, the epistemic, and the social consequences of how they are defined and redefined, who gets to define them, and in relation to what or who. So I wanted to share two very different conceptions of reasoning that emerged in the 1950s at the outset of so-called artificial intelligence as a way of complicating some of the usual origin myths and to give us some material to talk about today. It's a tale of two reasons, as it were. We would be remiss in a panel on origins probably not to at least mention Alan Newell and Herbert Simon. So I'll start with their definition of reasoning as developed in the context of systems engineering and automation at the Rand Corporation. And I've also put up two articles that I've written about these two definitions of reasoning in case people would like to read more and read more about the technical definitions under the hood. So Newell and Simon, after their experimentations with early digital computers, came to the belief that the human mind and the digital computer were the same kind of thing. They wrote, quote, "We wish to emphasize that we are not using computers as a crude analogy to human behavior. Our position is that the appropriate way to describe a piece of problem-solving behavior or intelligence or reasoning is in terms of a program, and they mean computer program by that. In terms of certain elementary information processes it is capable of performing. This assertion has nothing to do directly with computers. Computers come into the picture only because they can, by appropriate programming, be induced to execute the same sequences of information processes that humans execute when they are solving problems. Hence, programs describe both human and machine problem solving at the level of information processes." Newell and Simon came to believe that reasoning, and with it intelligence, judgment, problem solving, inhered in rule following. Every task could be broken down into a series of elementary information processing operations that could be executed by a person, a computer, an institution, a hybrid amalgamation of humans and machines. It didn't matter to them. Their vision of reasoning was rule-bound, best represented in the algorithmic form of a computer program. It was abstract, not dependent on the material substrata of the system carrying out those processes. And it was universal. The same rules applied to working minds, working computers, institutions. To be intelligent for them meant having the capacity to carry out those information processing rules in the prescribed order. Newell and Simon presented this vision at the infamous 1956 Dartmouth conference, thought to be the birthplace of AI, and it had an outsized impact on early research. But they also had a lot of critics, and my favorite was the Chinese-American logician Hao Wang. Wang was a philosopher, and over the course of his career, he became deeply critical of both analytic philosophy and logic and their progeny, AI, in part because he felt the abstractions in which they trafficked were just fictions, being treated as real, but that bore so little resemblance to the realities they had been extracted from to be useful. Wang proposed that Newell and Simon and those who approached the problem of AI as they did made a fundamental mistake. They had believed a fiction about the human mind that led them mistakenly to see the computer as the same kind of thing. He said logicians had worked with the fiction of man as a persistent and unimaginative beast who can only follow rules blindly, and then the fiction found its incarnation in the machine. Wang's own theory of reasoning drew from his training in Chinese materialism, his then secret engagement with Marxist theories, and his investment in Mao's worldview. And he said instead, a particular act of recognition or reasoning depends on one's genes, the history of one's mind and body, some essential relation to desire, even race, class, sex, and many other factors. Reasoning, Wang said, could not be reduced to a universal formalism because each person's reasoning faculty depends uniquely on their lived experience. He rejected all three tenets of Newell and Simon's vision. This was not an abstract or a universal or a rule-bound reasoning. And the fact that Wang himself has largely been erased from the history of AI, while Newell and Simon are its proverbial pioneering fathers, is itself a political history worth telling. And it highlights the fact that some people's definition of the human are enshrined in these technologies, and other people's have been erased, which I think is an important reflection for any discussion about origins. Thanks.
Thank you so much, Steph. Chris, that's your cue.
Okay, wonderful. So an advantage of going last, not last, but after somebody else is I still have time to add one slide. So I just added one slide in response to what was being said. Okay, I will try to get this done in approximately, let's say 8 minutes. As mentioned earlier, thank you very much for having me. It's wonderful to be here. As mentioned earlier, one of the projects I've been working on over the last couple of years is this book, which I had the pleasure of co-authoring with Matt Jones, who many of you know, who has now moved on to Princeton. And this book really grew out of a class. So I thought I would briefly just sort of prime some of the questions maybe we'll have in Q&A and discussion at the end with some of the highlights from the book. The book grew out of a class, and the idea of the class was to confront head-on the dumpster fire that is the internet today, quoting Lisa Nakamura, who teaches a class called The Internet is a Trash Fire, but also to give students some sort of hope, hopefully some rational exuberance about the future by having them think about how concerns about the present day sit inside a historical arc of similar challenges and also some repeated patterns from the future. Also trying to emphasize the social impact of the real world. I have not changed my slide from the original meeting when we were all about to get together back in May. And this was still merely hosted by NYU. So the other thing I wanted to do here, of course, was to thank Stephanie for a lot of her work. In particular, Stephanie wrote this piece in 2019 on artificial intelligence, where she highlighted that the term artificial intelligence and even what you conceive of as intelligence is itself a moving target. And I think that article and that framing had a big impact on me and a bit our ideas about the way we think about these subjects. Students and, I don't know, technologists and basically anyone who's ever heard of artificial intelligence, people are often confused for what even is artificial intelligence and how is it that the term is used to mean so many different things in different communities and in different decades. And I think Stephanie's article about artificial intelligence as a moving target and intelligence as a moving target as well really captures that. one of the things we want to emphasize in the book is that that phenomenon is true of artificial intelligence as a phrase, but also true of machine learning and data science. And we argue in the book, even the word statistics, which has been in the English language for a couple of centuries, but is still itself something that means different things in different decades, in different communities at different times. So briefly taking a look at how we constructed the class and then the book was to take this historical arc over a couple of centuries, starting with the creation of statistics, really growing out of trying to understand the state, and almost immediately thereafter trying to understand people and societies, and then taking students through the massive changes in making sense of the world through data with World War II, which really was about code breaking, wartime applications of code breaking, and the creation of digital computers in order to advance that end, and the creation of artificial intelligence itself, which, as Stephanie emphasized, a lot of it had nothing to do with data. In fact, data was considered to be the low road. The high road was really thinking about how we think that we think, particularly we being a group of 7 or 8 mathematicians who gathered in Dartmouth for one summer, and the way that they thought that we think was really what they foregrounded that conception as the current definition, or rather the contemporary at their time definition of intelligence. So we emphasize in the book that McCarthy, when he coined the term artificial intelligence, said that artificial intelligence was the conjecture that any feature of intelligence, here meaning human intelligence, can in principle be so precisely described that a machine can be made to simulate it. And again, McCarthy was a mathematician thinking about machine in the 1955 vision of what machines meant. But we emphasize in the book that, artificial intelligence, unlike some academic fields, is not named after the methods that you use. It's really named after an aspiration. And the aspiration is to get machines to be intelligent. It is not named after the technique you will use to get there. The technique you use to get there could be schema, or trying to get a machine to reproduce expert knowledge, or it could be statistics, or it could be something else as of yet uninvented. And I hope we captured some of what Stephanie Dick was getting at in her 2019 article with that. In fact, you can see that when they wrote the proposal. When they wrote the proposal, they were pretty Catholic, lowercase c, about what type of method was going to be the right method. Maybe it was going to be about neuron nets, or maybe it was going to be about self-improvement or abstractions, or maybe it'll be about Monte Carlo methods, all of these things under different names, or computational complexity. I want to also, Herb Simon was invoked, so so this was the slide I added. Herb Simon also had his own contributions, not only at the original meeting, but even as the phrase machine learning was starting to gain valence, to gain power. So the young Tom Mitchell at the time invited the great Herb Simon to come speak at one of the organizing meetings for what would become the field of machine learning as an academic discipline. And Herb Simon, being a bit of a contrarian, said, "Why should machines learn?" And if you look at this article, which was published in '83, he basically spends the whole article trashing the idea of machine learnings with neural nets sort of swept in, and emphasizes that in his view, the road to artificial intelligence is about just program it, which he says repeatedly in this article, that it's really about programming and understanding schema and not at all about data. So he really trashes the whole machine learning paradigm as the correct road to machine learning. Now, machine learning itself as a field is itself a moving target. One of the things we do in the book was to take an example of one leader in the field addressing the same topic, namely machine learning, what even is it, in different decades. So you can compare and contrast what Pat Langley says in '84 when Pat Langley is describing what even is machine learning. And he says, machine learning is this important field that is dealing with knowledge and rich relational structures. And he says in 2011, looking at how the field has changed, some people are just looking at statistics. Whereas in '84, when he was defining the field, it was clear that machine learning was really about, as he put it, important things like schema again. Let me see if I can advance my own slides. Right, so in '84, he contrasts the field of pattern recognition, which is really just for looking at visual images in his mind, with the more important thing of artificial intelligence and symbolic learning methods. By 2011, he had seen that machine learning had become a field of looking at data, and he'd sort of denigrated it as, unfortunately now in 2011, a lot of people are looking at statistics. Okay, data science itself is also very much a moving target. A good example, oft forgotten by people doing data science, is this provocation by Bill Cleveland at Bell Labs in 2001 rather, that we should create a new field of data science. And Cleveland was in industry, but he considered himself a statistician and wanted statisticians to take up the problem of making sense of the world through data on computers as a new field, a subfield of statistics called data science. Didn't work. Instead, data science was really advanced in industry. People like DJ Patil at LinkedIn and Jeff Hammerbacher at Facebook started creating a new field. And the way they did it was not by creating a department, but by creating a job title, which in industry is how you advance a new field, is you say, I'm going to hire people who have the job title data scientist. Why did they make up a new job title data scientist? Well, Jeff Hammerbacher reflected on this after he left Facebook in 2009 and said, we felt like there was a new field being created here with people doing this wide diversity of tasks, including data preprocessing, but also hypothesis testing, but also building data-empowered products, but also communicating the results of our analyses to other members of the organization in a clear and concise fashion. That term is very much a data science, a moving target. In industry, you don't have the sort of inertia of departments. You can just do things like relabel all of your data science, all of your data analysts to become data scientists, which is what Facebook did several years ago. Similarly, statistics departments have sort of given up at many departments, which I think is what the gesture here is supposed to connote. Carnegie Mellon and other departments have simply relabeled themselves departments of statistics and data science. Okay, we spent some time in the book talking about statistics as well as a field. Statistics enters the English language as a field about statecraft. It has nothing to do with mathematics or even data. It's about trying to make sense of the state. Whereas today, statistics is used synonymously with mathematical analyses. One thing we do try to introduce people to is the idea that many things that seem very contemporary actually have historical echoes, including small language models. This is a good example of Claude Shannon at Bell Labs in a classified document about the mathematical theory of cryptography, which was later declassified, sitting in his chair and observing that if you choose a word and then move along in a book to the next time that word occurs, and then write down the word after it, and keep doing that, just trying to predict the next word from what is a one-state Markov model, a mathematician might say, you get something that kind of sounds like English. And it's kind of funny that so much of historical echoes happen today, where now to be intelligent is actually to be predictable. An algorithm that predicts the next word or the next several tokens successfully are the things that for the last 11 months, we've been considering to be the highest form of machine intelligence. Okay, so I'm moving a bit closer to the end, and I want to save some time for us all to discuss. But like I said, I wanted to thank Stephanie for her work to emphasize this idea of a moving target. Intelligence itself is not only a moving target, but I think she makes a great point that it's often in comparison to human. If you think about the gap analysis between our prior belief about what a machine can do and our understanding of what a human can do, each of that sort of gap is what we're getting at with artificial intelligence. But each of those things is changing, right? As technology changes, what a machine can do and our prior belief about what a machine can do changes a lot. And also our understanding of ourselves is changing. Now we have, now that we've realized how much a machine that just predicts the next word sounds like us, it is getting people to think about, well, how much of us is really just stochastic parrots? How much of us is really just following the invocation of the muse and then letting the words flow out from our own large language models. I think with that, I'm on my last slide, which is good, as I'm looking forward to hearing the other speakers and the discussion. Thank you very much.
Thank you so much, Chris. And Kevin, before I hand it over to you, Chris, we had one question in the Q&A that actually I think would be great if you could answer that real quick, which is the question, what is schema? You're muted.
Oh, sorry, I muted myself at the end of my talking. So, schema is just how you represent things on a computer. So, I mean, a schema could be how you represent anything, but on a computer, a computer doesn't represent, pictures or words or song. You have to figure out how you're going to represent it in a computer. And that sort of feature engineering and knowledge representation problem is what Simon was talking about in 83 or 82. When he was talking about the problem of schemas, like how are we going to represent knowledge in a computer that, at the fundamental level just understands on, off, just a bunch of flip-flops. How do we represent something as complicated as an image or a word or a song or a theorem in a set of ones and zeros?
Thank you very much. And I think it's actually an excellent cue for you, Kevin. Over to you.
Great. As everyone said, this is such a cool opportunity. I'm really happy to be here and to offer maybe another voice to this mix of talking about what we mean when we say AI. And so I wanted to share with you a bit of work that I'd done recently, and also some surprising kind of discoveries, I guess you could say, through the archival process. So my most recent research was tackling a question that it seems maybe orthogonal to some of what we're talking about how the internet became the sort of dominant medium for our everyday social interactions. In other words, how did a infrastructure designed for researchers to talk to each other became the place that people go to find a date or argue about politics or look up the weather or something like that? And if I went around with the existing literature, I often got one of two stories, and one focused on researchers in more academic contexts, and one focused on the stories that industry tells about itself. So think about like the garage myth of the entrepreneur. And so through the work, I arrived at a third possible story, which was about the contributions of hobbyists and experimenters and tinkerers who had an amateur interest in computer technology. And what this showed to me was that we really rely on a long tradition of amateur telecommunications, particularly here in North America. So I wanted to zoom in on a tiny anecdote from this research as a way to move over to talk about artificial intelligence, which is that in North America in the late 70s, there was a particularly generative conjuncture for doing amateur technology, especially when you were concerned with communication. On one hand, there was the emergence of liberalization on the side of a lot of telecoms, giving us kind of a standard platform for experimentation in the case of the Bell system. And at the other extreme, popular culture got really interested in communication technologies as well, which I think of reaching its apex in the form of the logo for Smokey and the Bandit, which even features a CB radio microphone. And the CB is seen as like an outlaw technology. And that's the backdrop in which microcomputers enter the home. What would eventually become personal computing develops with this backdrop of changes in policy and standardization on one hand, and changes in popular culture on the other. And so the networks I was interested in are bulletin board system networks, which are a literal computerization of a print medium, which is the bulletin boards that you still find in grocery stores and libraries and other places. But also the medium through which people talked about bulletin boards was also kind of vestigial in the time. So the way many people learned to build bulletin board systems was by reading articles and letters published in computer magazines. So if you quantify this, this is no small subculture. This is actually a relatively substantial proportion of the computer using population getting online in the 1980s and 1990s through small scale local computer networks that were built largely by amateurs. And they built them for lots of reasons. Some was just from technical fascination, but others was to serve communities who had been systematically excluded from the dominant forms of media. So a lot of queer communities were highly visible in these spaces, in part because these provided a legitimate alternative to mainstream media forms. And yet, despite the kind of size and geographic distribution of these networks, they fall out of the stories we tell. And there's a couple of reasons, but two I want to focus on that I think offer some vision of what might be happening around AI is about terminology. And so as money rushes into the online space, a lot of bulletin board system operators just recast their systems in the new terms of the 1990s and become internet service providers. And the second is that the BBS is largely stigmatized. And so for people who are selling a vision, who are developing hype of the 1990s, the bulletin board system can be scapegoated as the place where piracy and pornography and other socially undesirable behavior is happening. And yet once you see it, you can trace all these continuities into the present. So what Olia Lealina would later call the vernacular web of the late 1990s is really coextensive with some of the creative culture that had developed around bulletin board systems. So the contributions of amateurs were really critical to transforming the internet into the space for everyday sociality, which is a necessary precondition for the conditions of AI that we live under today. So here's a quirk of that research, which is looking through all of these computer magazines, I was struck by how prevalent AI was as a theme. And so with one of my research assistants, we went back to Byte magazine of the late 1970s to see what people were saying about AI in the pages of the magazine. And sure enough, in the first 2 years, there were over 40 articles, editorials, letters, features, specifically on AI, automation, and robotics, a kind of family of topics that really hung together. And a few big themes emerged. One was that many readers saw microcomputing, or what we would later think of as personal computers, as AI coming into the home. Like personal computing and AI were really seen as tightly linked by many readers. And likewise, they saw AI as something participatory. It wasn't something that they would adopt as consumers or bring home, but it was something they would help to build, that it would be something we could learn to program through getting workbooks like this one. And then lastly, they talked a lot in critical terms about what this could mean for society, almost always using hypotheticals and examples from science fiction. So just to pull a few quotes to give you a sense of what this discourse felt like, one reader talked about AI offering something for every programmer in 1977, a golden opportunity for amateur computer enthusiasts to contribute to the field. They talked about it in really economic terms, like what was the cost of this going to be? And they compared it to a middle-sized car, a machine to do most of your housework. They valorized the figure of the AI expert and enthusiast who would be a virtual classical Renaissance man, widely read in all these different fields, but especially in science fiction. Science fiction was a part of the curriculum for the amateur AI enthusiast, partly because of its forecasting potential to imagine future scenarios, but also because science fiction was a pre-existing culture with networks of communication and meetings and other spaces where people could get together and talk. And fundamentally, they saw the emergence of amateur AI as something that would be community-based. So this is a quote from a letter published in an issue from 1978, where the writer was asking other readers to get in touch to form a collaborative network and develop this kind of grassroots AI. So for our discussion, I wondered where we see the role of amateurs in AI today under the prevailing paradigm. And I kind of have 5 leading questions of things that I think would be interesting to talk about in this space. And the first is historiographic, which is we have certain events in the history of AI that we rest on, these kind of, milestones in our narrative. And I wondered from a grassroots or amateur perspective, if we might select a different sequence of events. So the AI winter, a storied event in the 1980s of like a drying up of funding for AI, seems to belie the growth of AI as an interest among computer gamers. So if we look at magazines like Computer Gaming World, virtually every issue mentions artificial intelligence or intelligent opponents or artificial strategies and compares various sports games based on the quality of their computerized opponents. It seems like a space of like rich possibility and innovation. And like we can sort of extend that historical observation into a present day question about expertise, like who counts as an expert? Will we have expert users of AI models and things like this? What sorts of innovation are going to be visible and valorized? Like who will be the heroes of present day narratives? Using the BBS story as a model then suggests a third question, which is about stigma. So we know that the amateurs are ready to hand scapegoats when things go wrong. And so how will amateur enthusiasts of AI be marked in terms of maybe their use of these systems to create grassroots pornography, for exploitation, for, again, piracy, some of the same concerns from the 90s and earlier? But on the flip side, I wonder if we might get out in front of that and think about what sorts of contributions only amateurs will make. And so prompt engineering, prompt hacking, some of the ideas about like poisoning data sets seem like a space for grassroots or like bottom-up contributions. I've been particularly thinking of science fiction writer Alex Smith, who started this Instagram account, which he describes as a new space, a haven for queer POC fat bodies to exist in science fiction as heroic leads, something he saw as an absence. And while he's principally a writer, he uses Midjourney and these other generative tools to create what are like stills from movies that don't exist. That it is a really powerful argument for representation in Hollywood and other entertainment industries. And so kind of as my fifth question is about the canon we use to talk about science fiction. I think we all have go-to examples of Terminator robots and others. And yet there is clearly a hierarchy in which kinds of science fiction count and which can be included in academic discourse. We don't often talk about computer games or some of maybe low status streaming shows and other spaces, which may have greater visibility or occupy greater space in the minds of everyday computer users than HAL 9000 or some of maybe our canonical references. So in sum, really, I'm just interested to know, do we imagine a place for amateurs to contribute to AI today and in the near future? Thanks again very much for this invitation. I'm looking forward to chatting with everybody.
Thank you so much, Kevin, and thank you, Chris and Stephanie, for your terrific contributions. My head is spinning a little bit with questions, so I'm just going to take sort of the privilege of the moderator and ask the first few, but I want to encourage the audience to put questions as well as comments into the Q&A box, and we'll start to bring them in. And so my first question usually is for everybody, and this is one that I am asking with my sociology hat on, and as somebody who's interested in social relations and sort of power and the negotiations around power. And so, Stephanie, you talked a little bit about the sort of imaginations and possibilities that are motivated by intelligence, but also the harms that can sort of flow from there. And Chris, you talked about how, you know, expertise is sort of in moments of time fixed in these statistics, data science, like mathematical forms of expertise that get sort of become important in institutions like universities. And Kevin, you talked about, you know, power and amateurs and knowledge and sort of the bottom up. And so I'm just curious to hear from all of you, what is sort of looking forward, right? We looked at the past. What is the future of AI and society? How do you see that sort of emerge from knowing the past so well? And maybe Stephanie, you can start with you, and then Chris, and then Kevin.
Thanks, Mona. Historians are so bad at talking about the future, but we're supposed to practice this skill. So I'm grateful to have the opportunity to practice this skill. I mean, the thing that I'm concerned about, I think I tried to sort of suggest it in my opening remarks, is the kind of hegemonic function that AI seems to represent, this way that it demands that more and more of the world be defined on its terms. And I actually don't think there's a better example of that phenomenon than the emergence of the field of AI ethics, where in response to all of these observations and demonstrations that machine learning systems are reproducing historic racial bias, they're reconstructing sexism, various forms of inequality within the data on which it's trained, we see the emergence of this field that says, oh no, that's not good. Like, we have to make sure our machine learning systems are fair. We have to make sure they treat people with equality. We have to make sure. But what essentially happened is machine learning theorists took those terms and said, whatever fairness is, it'll be something that's defined mathematically, and it'll be something that is a constraint on the predictions that machine learning systems make. So whatever fairness is, we have to be able to translate it into a mathematical definition that can be applied to these systems of data-driven prediction to prevent them from making predictions that we think are unfair. And there's kind of a joke now that there's at least 21 different definitions of fairness at work in that field, as machine learning theorists sort of debate what the right mathematical definition for our social values are. But the kinds of critique and resistance that I've been really inspired by in the discourse that's emerged since then, especially on the part of the many Black women who have been identifying that bias, you know, advocating for these types of critiques, is that most of us don't feel represented at all by the way that these supposedly social values are being encoded in the language of machine learning. And I used to think the politics of refusal was almost impossible to hold. I get accused of being a Luddite all the time, and that used to be an insult. It almost feels like a compliment these days. But I've been really shocked by the successes of things like attempted bans on facial recognition technology and some of the other sort of attempts to actually refuse these systems, not because there's bias in them, not because we think the bias can't be fixed, but because the systems cannot represent a pluralism of value systems in the way that people, I think, are increasingly recognizing they care about. People want their values to be recognizable in governance institutions and in epistemic systems. And so I've been very excited about sort of critique beyond bias and the kind of refusal to allow machine learning to eat ethics and these sort of broader conversations about how to hold technologists and technology to account in a way that doesn't cede all of our values to their definitions and languages and the sort of hegemonic impulse of these systems. So there's lots to say, but I hope to see more of that kind of conversation that's not just about correcting for bias in various ways, but acknowledging how machine learning can't accommodate pluralism in a meaningful way, which works against democratic desires and the desires for different communities to feel represented. It was so helpful to have Chris articulate that the history of statistics is the history of statecraft. So if data-driven prediction is not able to represent people's values, neither are their governments, right? And so that's a profound lever, I think, for our conversations going forward.
Thank you, Steph. Chris.
Yes. Prediction is difficult, particularly when you're asking somebody to predict the future. And I'm not a real historian. I'm a fan of history, but my co-author is a real historian. So we closed the book by being very careful about not trying to predict the future, but instead trying to shine a light on the current contests among powers that we thought the resolution of those contests would most determine the future. Those powers include corporate power, state power, and private ordering, or as I like to call it, people power. So I'm a child of the 70s. That is, individuals can have in well-placed individuals in particular, can have a market effect on corporate power in particular, as employees of companies, as whistleblowers, via walkouts, all sorts of ways in which individuals are part of that unstable three-player game that's collectively going to determine the future. I think Kevin makes great points about the roles of amateurs and hobbyists. Actually, many venture capitalists agree. You often hear venture capitalists say, whatever the hobbyists are doing this weekend, that's where you should consider putting your investments, because that is going to be the future. And I think Kevin is wise to invoke Midjourney. I'm particularly a fan of the Pope in a Balenciaga jacket as an example from the spring of a piece of art that took over the internet for about half an hour, and many people didn't know that it was an AI fake. It was done on Midjourney by somebody who was absolutely not a technologist, who was himself trying to fill a lack. In this case, the lack was his recently deceased brother, and he was using Midjourney to generate pictures of him at an advanced age. But I'll close with optimism, because Mona's question was about the future. Not to sound too trite, but I believe the children are our future. So one way to think about the future is to think about what undergraduates are interested in. And I do think that undergraduates from across the spectrum are very interested in AI. This is not just a concern of students who are functionally engaging with data, but also students who are rhetorically and critically engaging with data, rhetorically in the sense that they want to know how these tools are useful for advancing an argument about the way the world is, whether it's amateurs using Midjourney or people generating, whole text with large language models, as well as critically. So in terms of critical understanding of data studies, that's now blossoming into a field, right? A field of not only scholarship, but students are interested, and it's really, I do think it is successfully impacting our broader narrative about AI. I do think the story of AI ethics is a battle. In fact, in our book, that's chapter 11 is called The Battle for Data Ethics, because the players are not just, students or, citizens who want to see some consumer protection, but it's also the companies themselves that are interested in recruiting and retaining talent, but also often getting ahead of regulation. So, you know, ethics theater, or ethics washing, as it's sometimes called, is itself a weapon of corporations for getting ahead of regulation. There's also, I think, very complex interactions with actual technologists. I think Stephanie's right to call out Arvind Narayanan's talk from the FETSTAR, I think it was still called the FETSTAR conference in 2018, 21 definitions of fairness and their politics, which is the end part of that talk title, tutorial on fairness, because it's not just that people don't know how to define fairness, and so they make up 21 things, but each one of those things has a slightly different implication about what we consider justified and who maintains power. For example, in the case of machine bias, which is one example where critics and defenders appeal to different definitions of fairness to make different arguments. So I'll close with optimism by saying that students seem very interested in AI ethics and where AI sits within this dynamic of powers.
I was thinking about having this conversation 10 or 15 years ago, and the return of the term AI would have been an unexpected outcome of the future. And it invites some reflection on how this term could regain purchase after being itself stigmatized for so long and associated with like science fiction and various industry failures. And it seems that it would have to have something to do with low interest rates and venture capitalism and industry culture and like a lot of money with a need to go somewhere. But that doesn't actually explain why undergrads would care about AI. And so, you know, you could imagine there's something there about precarity and like fear of lack of opportunity and concerns and things like that. But if I'm going to make some prediction, it's that we're seeing a growing tension between the spectacular and the mundane in AI. And on one hand, the spectacular is like the image generators, which often don't seem to have like an immediate instrumental purpose. And then the mundane is like the ongoing evolution of spell check and grammar check and like predictive texting, which is extremely effective at letting me author messages on my phone day to day. And that kind of like push and pull between the spectacular and the mundane seems like an important part of defining what is AI and what it's going to continue to be. So I'm kind of curious about the social function of the spectacular, and the spectacular could include spectacular fears, like some of the, world-ending anti-human visions that we've seen so far. But it seems like it must serve some function beyond merely like market manipulation and pump and dump scams and stuff like that. There's something that seems to grip the imagination, which allows people to like link the mundane kinds of AI that exist on our phones to these like momentary spectacular things that like Barnum sort of things that have been happening lately around like OpenAI and some of their tools.
Thank you all for your contributions and your responses to, well, it was more of a prompt, not a question. We do have some really fantastic questions from the audience, though, so I'm gonna start bringing those in. And so, Kevin, we're just gonna stay with you for a second. And so, Wesley King, who teaches an undergraduate class on AI, robots, and transcending religion, which explores many of the ideas that were talked about in this panel, says David Noble in The Religion of Technology discusses enchantment with technology as grounded in religious expectations and a quest for transcendence. That was written over 20 years ago, and they are curious about your thoughts, how this enchantment shows up in new ways around AI. You talked a little bit about this, Kevin, but maybe you can bring in the religious element in responding to this.
Sure. If I could connect your undergrad classroom to mine, I also teach this course about which is learning to program for non-programmers or first-time programmers, where we try to do like anti-utilitarian programs, like programs that have no purpose. We don't talk about, there's no user beyond yourself. And that is the question of the course, which isn't easily answered, is does learning to program offer you a new way to explore like fundamental questions that humans have always asked about the world? And I think there are ways that computer programming reveals things about infinity and creativity and originality in ways that are graspable to novice programmers in a really special way. Well, like when it works, of course. And so, yeah, maybe there's some continuities in the everyday computing culture. And by that, I mean like people learning to program BASIC from workbooks and taking random undergraduate classes and things like that in programming, where it does allow you to like peel back some of the curtain, I guess, around our like highly data intensive culture and get a glimpse of what might be going on behind the scenes. And that feels a little bit like touching the sublime, I guess, when culture is like so thoroughly infused by data and computer networking, that learning a little bit of like the argot and the habits of mind gives you that kind of a feeling. Although I think we've also seen the risks that come along with that, where people believe that that is the totality of existence, and that understanding how to like write programs is understanding the world on a level. I'm of course thinking back to Steph's presentation and the ways that people like Wang were pushing back on some of the very strictly formalist forms of analytic philosophy.
Thank you, Kevin. And I'm gonna add to this. We did have a co-opting AI religion last year, which I encourage you to explore also, which is on YouTube. And the folks who I hosted there, amongst them, Robert Garashi, as well as Beth Singler, do great work on that sort of intersection as well. But I have a question for you, Steph, and then I have another one for you, Chris. Steph, the question comes from Janine Denoves, and they're asking, what do you think was the original appeal of AI? Why did we want to translate human intelligence to computers when, by definition, we kind of knew this would be reductive? Was it because the math guys really thought this could be done, or was it because we dreamed about Alexa and Siri? Was it because of godlike aspirations, something else?
Such a good question. You know, I think it's quite a sad story, actually. I keep coming back to the sense that, you know, AI gets criticized everywhere in the critical discourses that Chris and Kevin and I inhabit for its arrogance, right? For its hubris. It's so blustery. It's always hyped. They're always overperforming what they can actually accomplish. And then there's this inevitable disappointment, and we go through all these cycles. So you hear AI being accused of a kind of arrogance and hubris all of the time. But I actually look at AI and it just drips low self-esteem to me. When I look at AI, I see a whole bunch of people who have no faith in the human capacity to navigate uncertainty, to manage disagreement, to sort of navigate complex political landscapes. And so, you know, the origins of AI in the American Cold War, it's not subtle. It's a fear of human beings being too limited, too erring, too restricted in our capacity to navigate information, that we see a really broad collective enthusiasm about automated decision-making, automated control. I learned so much from my colleague, Dan Volmar, who's a historian of the American defense establishment, and in particular, the Air Force's use of technology. And it's not a kind of grandiose dream that's at work there. It's a legitimate concern that the Cold War geopolitical landscape, and especially the imperial ambitions of the United States to control military and political and ideological outcomes the whole world over, that's a really massive information processing problem, among other things. And so I think there was just a deep distrust of human beings as capable of creating and holding on to control in the face of a world that felt like it was spiraling. There's such terrific literature about the sort of existential crises of the mid-century moment after the Second World War, where I think people were rightly asking really deep and horrible questions about how we could do these things and how to maintain control over a world that was shown to be more violent and more out of control than anyone had imagined. And so I see a kind of sad, mistaken belief that if only we could just come up with a machine that can do all of these really hard things for us, then we'll be in control. Then we don't have to worry. Then we'll be able to sort of manage the whole world. So it's both a really dark imperial project that I think justified so much of the early faith in AI, and also just this really sad existential reaction to a fear of being out of control, which the mid-century moment in which AI emerged, it's dripping with it. I have a little side project that I'm working on at the moment called Mid-Century Men Searching, and it's based on this collection of texts from the mid-century that all have the title, Man Search for Meaning, Man Search for Truth, Man Search for God, Man Search for the Soul, God Search for Man. You know, you really get the sense that there's a crisis of masculinity, there's a crisis of control, there's a crisis of human existential reaction to what the Second and First World Wars presented. And so I think the origins are those. It's a sad story about a desire for imperial control and a lack of faith in human beings as agents of decision-making, judgment, conflict navigation, you know, our capacity to engage with uncertainty. And I think that's still true today, by the way. I think everywhere people just want a tool that, what if we could just get the algorithm right and it churned out a just society, right? And we no longer have to actually do the impossible work of interhuman conflict navigation. What if we could just prescribe these outcomes through contracts or algorithms or constraints on our classifiers? And so I see that as the kind of sad, low self-esteem about us that runs through the whole history of AI.
Thank you, Steph. And it's so interesting because it also tells such an interesting sort of intricate kind of story about agency, right? Like agency sort of comes kind of back in different ways all across. But we're getting great questions and we have about 10 minutes left. So Chris, I have one for you if you're ready. Shira Abramovich is stating that they're really struggling with balancing the need to refuse harmful systems with the need to go beyond critique and give alternative visions of tech of the future. How do you, as critical tech scholars, work with that tension, if it even is a tension for you? And Chris, I'm giving that to you because you are training the next generation of, I'm going to use the word, data scientists.
Golly. So maybe I can try to capture the question as like, what is to be done? So in addition to, you know, maybe it's the second GIF on my opening slide. So the first GIF is a dumpster file. The second GIF is Buzz Lightyear, who's from a movie from a long time ago, who was ridiculously optimistic all the time. Anyways, what is to be done? So as an educator, I think what is to be done is to arm people with a vocabulary around power and ethics, and to try to give students a sense for what we talk about when we talk about ethics. Why do we talk about ethics? What's the backdrop of applied ethics as opposed to, you know, high philosophy of ethics, so that they have a sufficient vocabulary that they can raise questions as they go on to be product managers or software engineers or what have you, or senators who are shaping power and shaping in particular data products and companies that deploy, or more generally are empowered by abundant capital to deploy artificial intelligence. So giving young people a vocabulary around ethics and power, I think is one thing that's useful in the workplace, like in companies that are actually deploying AI. The first book you mentioned, which was written but with technologists, fellow technologists, has much more of a pointed view on how to integrate ethics into process and how a company, or any community, but in particular a company, might consider having an ethical process. So that's in part about how you define ethics, but also part about how you design for ethics. It's well understood that you can't simply invoke ethical principles and then say, okay, we're done. But you really need to think about, like, how does a process work? You certainly know the work, who owns ethics. So you need to think about, like, within an organization, who's responsible for ethics and how does that relate to actual corporate process, which means deploying products. Is there room for ethical audits before, during, and after you've deployed a data-empowered algorithm? What are the pause points in terms of people's promotion when you hire people, when you promote them? What's the role of ethics and constraints on power there? So I think there's a lot to be done. I hope I'm responding to the question a little bit, but I do think it's important to, the first step of any multi-step problem is to recognize that there's a problem and to name it. But as to what is to be done, I do think there's a lot of ways that students who will go on to work at these companies, and even within companies, people can integrate ethics into their process. Part of that is to name that there's a problem, to be clear about what you mean by ethics, why it's a good idea to have ethics within a company, and then how are you going to actually design a process in which ethics constrains and guides the operations of the company.
Thank you for that, Chris. I have one follow-up question, which is very specific. It's about copyright in relation to AI. Do you have any thoughts on the future or past of copyright in relation to AI? And sort of the question is around, is AI being used or designed around shifting money upwards to corporate hands? What are the financial motivations around that? And how does this sort of intersect with copyright? Short, please, because we have a few more.
That's a very tricky question. Copyright in AI is dynamic and not yet writ. Even copyright and fair use, which is the most, it's sort of the legal nugget that's at the heart of these disputes, is itself adjudicated regularly. This past summer, there was a decision by the Supreme Court about the Warhol Foundation using an image of the musician Prince. And they ruled in favor of the original photographer, that Andy Warhol had not sufficiently transformed the image by making it orange and plasting it over and over again. And so the original photographer maintained copyright. And so there's a bunch of disputes going on right now about whether AI is sufficiently transformative, sufficiently fair. I should say fair use is actually a legal concept with 4 tenets, only one of which is how transformative is the use of the art. And so the Copyright Office of the United States actually requested comments a few months ago, and I think I downloaded as many as you could, like 10,000 comments were submitted, which included PDFs from Google, Meta, Andreessen Horowitz, and a few, Microsoft, and a few other comments that I encourage you to read if you want to see how the battle for copyright is being fought right now. But in short, that future is not yet writ, and it's being decided by courts right now. Actually, you probably know somebody just resigned from Stable Diffusion last week, saying that they were resigning in part because they felt like Stable Diffusion wasn't respecting the copyright of visual artists. So that is absolutely in play. I don't have a good answer, except that, like, you're right to ask that question because it is absolutely being contested right now, day by day.
Yeah, that's a very good point. And a very good, good condition for a very lively classroom, actually. Okay, last question for everybody as we are beginning to sort of close off. And we have a question from Laura Stark, who is a historian in sociologist of science and works on the history of so-called ethics in the human sciences. She's saying that this is a fascinating conversation and has a wonderful sort of closing off question, which is for everybody. Who is inspiring you? What are your favorite articles, books, podcasts, creative projects that you've engaged recently on these topics that we discussed? And then I'm going to add another layer from another audience member who's asking what types of science fiction should be integrated into the canon. So articles, books, podcasts, creative projects, and science fiction for folks to engage with. Steph, you first, and then Kevin, and then Chris, and then I'm going to close us out.
Hi, Laura. What a nice way to round out this conversation. And maybe because Laura's here and has asked this terrific question, I will use my time to answer that. I have been really educated by colleagues in the history of medicine, and in particular in the history of bioethics, in thinking through what is wanting in the field of AI ethics. And the work of Joanna Radin and Laura Stark and Isabel Gable in particular has been really influential for me, especially for unpacking the doctrine of informed consent. The sort of underlying logic of biomedicine I've learned from those 3 women and others has sort of been biomedicine is inherently good and it should proceed as fast and as far as possible. And the way to make sure nothing goes wrong is to try to mitigate unnecessary harm through something like a doctrine of informed consent that puts a burden on the patient in a certain set of ways to opt in to potentially harmful trials or experiments or forms of treatment. And AI is following that playbook entirely. The underlying assumption is the same, that AI is inherently good. It should proceed as far and as fast as possible. And what we need to do is think about how to mitigate unnecessary harm through things like AI ethics in response to bias, or informed consent when one's data is being included into a system. And the work that these historians of medicine have done to show how lacking the doctrine of how necessary, but also how insufficient informed consent has been in preventing the structural harms of a biomedicine that works better for some people than others and always has historically by design, I have found really instructive for thinking about the limitations of AI ethics. It's so nice that, Laura, that you're here, and I find your work and so many others so essential for critiquing AI ethics as a response to this type of technological development.
I can jump in here. Something that's been really helpful for me, particularly this semester, is teaching with this textbook called Aesthetic Programming by Winnie Soon and Jeff Cox, which integrates critical studies of technology with very accessible programming exercises. And so illustrating some of the key techniques that come up in and around some of these systems has just been very generative, and I can see it clicking with students, but it's really been helpful for me just thinking about this portfolio of techniques and how they can be read alongside some of the critical and historical work that we're talking about. So it's just like a really great free and open self-directed curriculum called Aesthetic Programming. And then on the question of science fiction, I've been wrestling with that too. Maybe I'm a reader and I have that readerly taste, but I do think that an important sphere for understanding science, for understanding artificial intelligence for many people has been video games. And even some of the consumer technology like Cortana begins life as a character in the Halo universe. And those origins in like the interactive worlds of science fiction gaming are often not entirely visible, but we spend hours and hours in those worlds. And so if we come to think about what it means to live alongside non-humans in social formations, it seems like people who are really dedicated gamers would have a different orientation towards some of these systems than others. And so I'm kind of curious to hear more contributions from people in critical games kinds of spaces to thinking about AI.
It's a hard question for me to answer because I find that I just do not have any time to listen to podcasts anymore or TV or anything like that. Other people talk about Black Mirror a lot, so I guess it's useful. Maybe we could start with that. In terms of inspiring, maybe it's hard to make a short list of people who inspire me. I can tell you places that I learned things. So like I first really understood the history of Belmont from reading Bit by Bit, which is a textbook on computational social science by Matt Salganik, who actually had been on the IRB at Princeton before that and really gave a historical view and helped me understand how applied ethics came to be the way it is. Thereafter, once I started digging into the primary literature, I really enjoyed engaging with reflections by Karen Labatz, who was one of the original commissioners on the commission to write the Belmont Report, which is the definition of applied ethics in the United States for human subjects research for the last 40 years. And then reflecting on it 25 years later, I think she had a really good perspective on power and oppression and fairness and what actually does that mean. Very thoughtful. In terms of people inspiring me, there's really too many to mention. I've had the pleasure of knowing Deb Raji since she was an undergrad. I met her in like 2017, and it's been great how like she was, at the White House and telling off Elon Musk a couple of months ago. And I don't know, like she's been writing good papers about ethical audits and speaking truth to power, and she continues to do so even as a graduate student, which I always like. LaTanya Sweeney, when she was a graduate student, she pointed out the ridiculousness of calling in a data set anonymous because you strip the name out of it. I don't know. There's really a long list of people who've inspired me over the years.
Thank you so much to the three of you. We have more comments and questions from folks, all of which are much appreciated and important about, the question, are there imaginaries of AI that support insurgent movements? We have questions around motivations and business models. We have comments around the usefulness of AI in education and making, for example, education more equitable. And of course, we also have the question from OpenAI, what's going on with the hiring and firing? We did not get to that. That's for the news. So I want to close us off by thanking all of you for joining, our wonderful audience members, for your questions, for your participation. A big thanks to Stephanie Digg, Kevin Driscoll, and Chris Wiggins for joining the conversation today on origins. All of them are out with amazing books. We have Stephanie's Abstraction and Embodiments, which is an edited collection, which is wonderful. Stephanie also has a forthcoming co-edited special issue with Cambridge University Press, which is about the history of AI, which is terrific, coming out at the end of this year. You have Kevin's book, The Modem World, which is out with Yale. I highly recommend that. And of course, Chris and Matt Jones' book, How Data Happen, and many more. You can find all of these folks online. I'm sure they are happy to answer any additional questions you may have. We are going to be back with the next Co-opting AI event on athletics on December 6th. That will feature Hannah Bornstein, who works on long distance runners in Ethiopia and data. We have UVA's Natalie Kupperman, who works with our athletes here from a data science perspective. And we have George Atala, who is working with NFL players at the NFL Players Association and thinks about sports and labor and data. December 6th, this will be a lunch event at noon. I hope to see you all there. My heartfelt thanks to staff, Kevin and Chris. Thank you so much for being here. Thanks to IPK and Karsh for facilitating this. And I hope to see you all soon. Happy Thanksgiving for those of you who celebrate. Thank you so much and take care.